Good morning. Today we're going to be learning about viruses. So at all of those people that are always like, what are we ever going to do with this in real life? Well, educate yourself about what a virus is. So when people have all this stuff to say about coronavirus, you are at least informed. So here we go.
Chances are, in your life, you've had the common cold before. It can cause sneezing and coughing and can make you feel awful. The worst thing about the common cold is that you can take medications to help with the symptoms, but you really can't treat the actual cold with antibiotics like you would a strep throat infection or an infected tooth. Why?
So remember that you're able to use antibiotics to treat for bacterial infections, so like a strep throat, an ear infection, a really bad infected cut maybe. Those are all things that antibiotics would be helpful for, but they are not helpful for viruses. Antibiotics are just for bacteria.
Well, let's talk about what causes it. A virus. The common cold is caused by a virus. While all living things are made of one or more cells, see the modern cell theory, viruses are not cells. Viruses aren't technically classified as living things since they lack many characteristics of life. But there is some debate in calling them non-living as well. Medications like antibiotics attack bacteria like E. coli, which are living cells. Antifungal medications can be used on fungi like athlete's foot, which are made of living cells. Viruses are not bacteria or fungi. You can't classify a virus as a prokaryote or a eukaryote either because
So viruses are not living things. They are not considered to be living cells. They're kind of their own category. So they don't even get to go into the box of prokaryotes or eukaryotes. So remember that prokaryotes have no nucleus and no membrane-bound organelles, while eukaryotes do have a nucleus and membrane-bound organelles. So viruses don't fall in either of those categories as well, because technically they are non-living.
it's not a cell. So what is their structure like? First of all, viruses are much, much smaller than cells. You
Very
typically are going
small.
to need an electron microscope in order to see a virus. Viruses come in many shapes. Our favorite one to draw is the bacteriophage. It sounds very fancy, but it's a type of virus that tends to attack bacteria. Despite this being our favorite to draw, know that the shape of viruses vary greatly. One thing all viruses have in common is that they have some type of genetic material.
So although they are not living, they do contain some type of genetic material. So sometimes it's DNA, sometimes it's RNA, but even though they are non-living entities, they do have genetic material.
Genetic material can be in the form of DNA or RNA. Viruses usually have some kind of protein coat, also known as a capsid. The capsid can protect the DNA or RNA genetic material.
So those capsids are basically the virus's equivalent to a nucleus in terms of holding their DNA and or RNA and keeping it safe.
Viruses can also have other structures. Some viruses package special enzymes with them. Some viruses have an outer envelope. These additions can be useful to the virus in virus replication. One thing that makes virus replication.
So just like our cells replicate, we've talked about mitosis before, creating two identical daughter cells for our body cells, as well as meiosis for our sex cells, 4 unique daughter cells for your sex cells. Those are both forms of replication. Viruses replicate as well, but they do it a little bit differently.
Or reproduction unique is that they can't replicate without a host. And it's their reproducing that tends to be a problem for its host. Whether the host is you, in the case of the common cold, or an insect, plant, this bacterium, viruses tend to be very specific for the host.
So viruses cannot replicate if it doesn't have a living host, okay? So I'm sure you've heard lots and lots of things about where the coronavirus can live and for how long and etc. But it does need a living host in order to replicate. So although it might be able to live on a countertop or on a doorknob for however long that they're saying, that means that it can just be there. It cannot replicate. So if it gets cleaned or if it's not touched or whatever, it's just going to stay there and it will eventually die or get cleaned unless it makes contact with a host. At this point, the coronavirus passes via human. So like your dog isn't in danger of catching the human version of the coronavirus. But if you were to touch that doorknob and get the virus onto your skin, and then if you touched your face and into your getting it into your bloodstream and your body, then you would become that host. But when it's just chilling on the doorknob or chilling on the countertop, it cannot replicate. It might be able to stay alive for a minute, but it will eventually die. But the best news is that it can't replicate if it doesn't have a host.
Host that they're going to infect. But anything that is alive can be a host, because cells have the machinery that viruses need in order to replicate. We're going to talk about two types of viral replication cycles. The first one is the lytic cycle. In the lytic cycle, the virus, remember very selective, attaches to a host cell. It often binds to a receptor that this cell has, which gives it access to attach. The virus can inject either its DNA or RNA, depending on what kind of genetic material it is.
So viruses are able to inject other healthy living cells with their viral DNA. And remember that the DNA is found in our nucleus, and the nucleus holds all the instructions and tells everybody what to do. So if we were to change those instructions, then the nucleus would then change what the healthy cell should do. And that's where viruses come in, and they basically change the DNA, which then changes the instructions for the entire cell.
Into the cell. Some types of viruses are actually taken inside the cell themselves. Now, you would think that the cell would notice viral DNA or RNA or an entire virus that has been taken in, but in many cases, it does not. It takes the...
If you see down here, it says some hosts are tricked into recognizing the virus as a food particle. So that's another reason why they might not notice it, but a lot of times they can kind of sneak in unnoticed, and then bad things happen to the cell.
Genetic material from the virus, and it starts following the instructions, which in this case is very bad because the instructions tell it to make copies of the virus. The cell uses its own resources to start building. It starts making so many copies of the virus that...
So we've talked about how important resources are for a cell so that it can reproduce and stay healthy and do all of the things that it needs to do. We've also talked about how the cell likes to conserve as much energy as possible so it can use it when it's needed. So the virus actually tricks the cell into using its own precious resources to reproduce the virus. And the instructions that the DNA that is inserted into the cell tells it to do is just to keep replicating the virus itself rather than, making the things that the healthy cell needs to live, function, grow, etc.
It can cause the cell membrane of the host to rupture, explode, lyse. So what happens is now that these new viral copies, they can get out of the cell and go and infect other cells. This is known as the lytic cycle. By the way, the lysing of the cell membrane is a very bad thing for the cell.
So lysing of the cell membrane means for it to rupture, to burst, to be able for things to flow freely in and out. That's a really bad thing because we talked about how important the cell membrane is to the cell, and it controls what goes in and out. So if there are holes in the cell membrane, then you no longer have control of what comes in or out of your cell. So that is not a good thing. In addition, once the cell lyses, the virus is free to go infect other cells. So it's just kind of like rampantly running through your body.
The cell cannot survive without its cell membrane. The other cycle is called the lysogenic cycle, and I like to remember this is the longer word, so I like to think of this as the longer, sneaky cycle. Viruses that go through this cycle tend to do the same thing at the beginning. They inject their genetic material, but this time, the genetic material stays hidden in the host genetic material. What happens is that when the host makes new cells, it replicates its own genetic material and the viral genetic material. Then those daughter cells make new cells, and they also replicate their own genetic material and the viral genetic material, and so on. This is the lysogenic cycle.
So they basically find a way to in the lysogenic cycle to change the host's DNA, but not all of it, just part of it, and so they don't even notice. So when they go about cell reproduction, like mitosis, so if I scrape my knee and need new cells, every time those cells divide, they have both the hosts or my DNA in there as well as a chunk of the viruses. So then the virus is basically getting a free ride into replication as well.
That may not seem like a problem, but it really becomes one if the virus gets triggered to go into the lytic cycle from that point, because then all those cells that have the viral genetic material can start assembling viruses. And as far as what triggers it to go into the lytic cycle, it can vary. It could be a chemical trigger, for example, or a lack of food for the host. Going back to the common cold, a lot of times it has to run its course. Your immune system will typically take care of it, and medications can help with the symptoms so that they don't feel as bad. But unfortunately, some viruses are extremely complicated, like HIV, a virus that can lead to AIDS. Like most viruses, it is very specific. It binds to a CD4 glycoprotein that is found on the surface of specific cells, such as helper T cells. The problem about this particular target is that helper T cells play an important role in protecting the body and the immune system. Since HIV goes after these immune cells, it can make a person that is infected with HIV vulnerable to other infections. There are medications that have been developed to help keep HIV from replicating as quickly, and there continues to be research into looking into ways to keep the virus from attaching, because if the virus can't attach, it can't insert its genetic material. A problem that continues to be a challenge is that many viruses, including HIV, can mutate. So a treatment developed against a certain virus type may not work on a mutated form.
So we've talked about mutations before. Remember that there's substitution, insertion, and deletion. And just like living things can mutate randomly, viruses can as well. So if they mutate, then whatever maybe research or medications become less effective on mutated strands because it was created with the original strand of that virus in mind. So
with our talk about viruses, you might wonder, is there anything positive about viruses? Well, some viruses can play a useful role in gene therapy. Definitely something to explore more.
Remember gene
Also
therapy
remember
from
how we
biotech
mentioned that
unit?
viruses can go after other organisms, like insects, for example. A virus that targets pest insects could be an alternative to a chemical pesticide. One such example virus that you may want to explore is the nuclear polyhedrosis virus. Still, it's important to consider that whenever talking about any kind of pesticide, chemical or viral, there could be consequences in the ecosystem. Well, that's it for the Muta Sisters. I'll remind you to stay curious.
So there's some basic information on viruses. Remember that this information is about viruses in general, not specific to the coronavirus, but just how the life cycle of a virus works and the two different cycles that it goes through. They are classified as non-living organisms, so they are not living, and they do need a host cell in order to live for longer periods of time. It can live on non-host, non-living surfaces for a little bit, but in order to live for a long time, and most importantly, in order to reproduce, it does need a living host. So hopefully this gave you some information, but they are classified as non-living. That is the most important thing for you to take away from this.